Today we're going to look at 3 common mistakes students make in vector questions in Cambridge 9709 paper 3. These are small errors, but they often cost easy marks in exams. The first mistake that students make is not using position vectors correctly. Now, what do we mean by that? So suppose you have a vector AB. AB is a vector going from the point A to the point B. Now, all vectors can be represented by the position vectors of their start and end points. So, AB would be represented as endpoint position vector, so OB, minus the start point position vector, OA. And this is true for all vectors. So, suppose you have a vector, let's say LM, starting from L and ending at M. You can represent it as OM, the endpoints position vector, minus OL, the start points position vector. The second mistake has to do with misunderstanding the vector equation of a line. Now, the typical vector equation of a line looks like this. R is equal to A plus lambda B. Here, suppose this is your line. R represents any point on the line, the position vector of any point on the line. So in case you have, let's say you have a point N, you can replace R with ON is equal to A plus lambda B. This is tested very often on your papers. So you need to keep in mind that any point on the line its position vector can replace R in the vector equation of the line. Right. The second thing you need to know is what is A. So A is the position vector of a known point on the line. So let's say you have a point A, capital A. I'm representing the point as capital A and the vector as lowercase a. So in this vector equation of a line, you can replace A with the position vector of a known point, so OA plus lambda B. Right? And that leaves B. So what is B? B represents a line parallel to your line. So if you have a line, the line whose vector equation is given to us, I'm marking an arrow on it. So if you have a vector parallel to it, that vector B is what you see here in this standard equation of the vector equation of a line. Okay, so those are the 3 components, and lambda is a factor that differs for every single point on the line. So for every point on the line, the lambda value will be different. Mistake 3 has to do with forgetting to use the direction vector for perpendicular lines, parallel lines, and angles between lines. Now, first of all, what is a direction vector? So this portion here, B1, which is attached to lambda and in this case mu, is called the direction vector, and it represents the direction of the entire vector. So we don't use A1 plus alpha B1 or A2 plus mu B2. We'll just use this small vector here, B1 or B2, to carry out any calculations involving angles and directions. So for example, for perpendicular lines, we know that their dot product is 0. So the dot product that I would do is B1 dot B2. for these two lines that I have written up here is equal to 0. Okay, I don't have to do the entire thing, a1 plus alpha b1 dot a2 plus mu b2. You just have to do b1 dot b2 equal to 0 and solve the question. Similarly, for parallel lines, here for parallel lines, the property is that the vectors are multiples of each other. So b1 would be k times b2. That's the property that tells us that lines are parallel. Again, we're just using the direction vectors of each of the given vector equations. And finally, to find angles between lines, so if these are the two vectors whose vector equations are given here, all you have to do is use b1 and b2 to figure out the angle theta between the lines. So b1 dot b2 is equal to modulus b1 modulus b2 cos theta, and then you solve for theta. So just remember, that's what the direction vector portion is used for when we solve questions, vector questions. Anything that involves direction or angles, we don't use the entire vector equation of the line, just use the direction vector portion, which in this case is b1 and b2. So the three mistakes to watch out for are the incorrect use of position vectors or forgetting to use position vectors. Secondly, misunderstanding what the different components of the vector equation of a line are. And finally, forgetting to use the direction vector for any question involving angles. Avoiding these can help you secure easy marks in Cambridge 9709 paper 3 vectors.